Hi, what is linearization? Linearization or linear approximation. Linear approximation of one variable y equal to f of x which is equal to L of x equal to f of x naught plus f dash x naught into x minus x naught. This is constant. This is a constant vector. It's a constant vector. Okay. So in the case of the two variable, this can be the linearization. This can be visualized as a tangent plane. However, with a higher dimension, we don't have this visual luxury. So we have to think about it just as an approximation. What is the meaning of linear? Linear means all the coordinates are just multiplied by a constant. All the coordinates are. What is the meaning of linear? A function is linear means if it's all the coordinates, a function is linear means all the coordinates are just multiplied by the constant. So here, this is the linearization of one variable. This is constant vector. Okay. So this is actually considered, in the case of the two variables, this is considered as a tangent plane. So what was the definition of this linearization? Linearization or linear approximation of a function f of x, y. That is, we are approximating this function with another function L of x, y. This is a definition. F of x naught y naught plus fx at x naught y naught into x minus x naught plus fy at x naught y naught into y minus y naught. And this is equivalent to this L of x, y. This is the standard linear approximation. So, how can you find the linearization of a function f of x, y? How can you find the linearization of a function f of x, y? So, consider the function f of x, y equal to x square minus xy plus y square by 2 plus 3. So, at the point 3, 2. So, how will you find the solution? So, first to find f of, in the place of x naught, y naught, here it is 3, 2. So, f of 3, 2 is equal to, substitute x equal to 3 and y equal to 2 here. You will get 8. What is fx? 2x minus y. And fy equal to minus y plus y, which is equal to 0. What is fy? Fy equal to derivative of y, that is minus x plus y, minus x plus y. So, fx and the fy, fx at the point 3, 2. That's equal to 3 into 2 into 3, 6 minus 2, that is equal to 4. Fy at 3, 2, that's equal to minus 3 plus 2, that is minus 1. So the value equal to L of x, y, this is a linear approximation. This is equal to 8 plus, what is fx? So that is 4 into x minus 3 plus fy is minus 1 into y minus 2, which is equal to 4x minus y minus 2, which is a linear approximation. So, through the linear approximation, we are approximating a complicated f of x, y function to a function, another linear function L of xy. Linear function is very easy to compute and to find out the characteristics of that function. So we are approximating this function to a simpler function L of xy. But these are not equal. So when I am writing this as equal, there will be an error term here. So what will be that error? That is the next portion. Error in standard linear approximation. Error in standard linear. This is the error in the standard linear approximation. If f has continuous first and second order partial derivatives throughout an open set containing a rectangle R centered at x0, y0, and if capital M is any upper bound for the values of mod fxx, mod fyy, mod fxy on R, then the error E of xy incurred in replacing f of xy on R by its linearization L of xy satisfy the inequality mod E of xy is less than or equal to by 2m into mod x minus x0 plus mod y minus y0 whole square. This is the error term. So we have to find out the error term in this corresponding to each function. So one example, f of xy is equal to x square minus xy plus y square by 2 plus 3. At the point, we have done the linearization before. So add one more question to that question. Find an upper bound for the error in the approximation f of xy equal to L of xy over the rectangle R is such that mod x minus 3 is less than or equal to 0.1, mod y minus 2 is less than or equal to 0.1. Express the upper bound as a percentage of f of 3 to the value of f at center of rectangle. This is a question. So we have to answer it. Solution. We have mod E of xy. This is a equation. M into mod x minus x naught plus mod y minus y naught whole square. First of all, we have to find this m, capital M. Capital M is the upper bound of all mod fxx, mod fyy, mod fxy. So first of all, we have to find fx. We know that fx equal to, what was that? Fx equal to 2x minus y. And at the point 3, 2, the answer is 4. And fxx equal to 2. Fy equal to minus x plus y. And at the point 3, 2, the answer is minus 1. And fyy, which is equal to derivative of this with respect to y, that is 1. So fyy is 1, again fxy, that's equal to derivative of this അയ്യോ പോയില്ലേ പോയില്ലേ